Hi guys, now in last class we have studied about fundamental physical quantity and derived physical quantity. So we know that we have 7 fundamental physical quantities that are length, mass, time, current, electricity, temperature, amount of substance and luminous intensity. You just keep all these 7 fundamental quantities in your mind because we need it. Now, and you have also learned about the derived physical quantity because your derived physical quantities that depends on fundamental physical quantities. Like that, we have given an example: speed, velocity, density, and linear momentum, etc. So here we will see that we have fundamental physical quantities as well as derived physical quantities, but how we can use this and how we can call this, because if suppose that I give you 20 rupees and I just told you that you just go in the market and buy pen of rupees 200, then what you ask to your shopkeeper, then definitely you will tell him that yeah, we have or we want this number of pens, either it is one number of pen, two number of pen. So there is a, because pen is just, it is a countable things. So you will demand to your shopkeeper in the form of counts. So counting is a standard. Like that, if you go to different shopkeeper and if you wanted to buy a cloth, then how you can ask to your shopkeeper, cloth shopkeeper, about 20 rupees that you want cloth to this 20 rupees. Definitely you will ask them that I want cloth, this amount of cloth, like 20 centimeter, 1 meter, 2 meter, half meter, whatever. So there is word that come, it is called meter centimeter. So meter centimeter, this one is conversion, we will see again. But meter or whatever centimeter, this one is standard, and this standard we use in the measurement of physical quantity. So this measurement is called units. So not only in length, because meter centimeter, that is a unit in the measurement of length. Accordingly, if someone go and ask to the shopkeeper that they want something in kg, like sugar in kg, like oil in liter. So this one is the measurement of mass. Okay, so we need like that for all 7 fundamental physical quantity we need standard. Okay, so this is called units. So now your heading is units. So accordingly you can just say the measurement of a physical quantity we need a standard. That standard is called unit of a physical quantity. Okay, so the measurement of a physical quantity. So to measure to any physical quantity, you need a standard, and that standard is called a unit. Okay, so now from here I would like to find the unit of a fundamental physical quantity. So you just change your heading. Unit of fundamental physical quantity. So how many fundamental physical quantity we have? We know that we have 7 fundamental physical quantities. So I am just going to make a chart. You just write down accordingly. So there is a serial number. Fundamental physical quantity is like that. And then units. And its symbol. So we have 7 fundamental physical quantity. The first one is suppose length. Second one is mass. Third one is time. Fourth one is current, electricity. Fifth one is temperature. Sixth one is luminous intensity. Seventh and last one is amount of substance. So you can see here there are 7 fundamental physical quantity: length, mass, time, current, electricity, temperature, luminous intensity, and amount of substance. Now accordingly, its unit. So length is always measured in meter. There is small m. Mass in kilogram. Here k is also small. Now time in second. Second s is also small. Current, electricity, it is in ampere. Here A is capital. Now temperature is in Kelvin, where K is also capital. Luminous intensity is measured in candela. Here C is small. And last one is amount of substance, that is measured in mole, where m is small. And then because at the time of the study in book or in notepad, it is very difficult to write every time meter, kilogram, second, ampere, kilo, Kelvin, candle, and mole. So someone want to write on short, so symbol will be here to write directly. Okay, because this one is a unit of fundamental physical quantity. Whenever you will answer in direct physical quantity, its unit will be more complicated than that of this one. That's why we need a symbol. So meter is in symbol written by small m. Now kilogram, there is kg. K and G both are small. Accordingly, time, second, S is also small. Ampere is written as either capital A or capital I. Now Kelvin is written by capital K. Candela written by small c, small d. And mole is written by small m o l. So this is our symbol by which we can represent. Actually, this I is widely used in dimension, so we no need to write down in unit symbol. So we can remove it from here. You just keep in mind ampere A. Alright. So you got it. And now, next, I would like to find the unit of derived physical quantity. So just next heading, derived. So unit of derived. Derived physical quantity. So there is no limit of derived physical quantity, but here I would like to write some derived physical quantity and its unit with symbol. Suppose for derived physical quantity, this one is derived physical quantity, like that, derived physical quantity. So accordingly, speed, the first one is speed or velocity. Why we have written speed or velocity? Because both containing, this one is containing distance by time, and this one is displacement by time. That means both having length by time. That's why. So from here you can see for speed or displacement, your unit will be, the unit of distance is in meter. So there is meter divided by time. So time is measured in second. So this one is written as meter per second. Now in symbol, or this one is also written as meter and then second. Second having power 1. So meter per second. Now in symbol, this one is written as meter per second. If you take, instead of speed or velocity, suppose there is a linear momentum or density. So you first take density. density. So you know that density is mass by volume. So mass is, the unit of mass is in kilogram, and then divided by volume. So volume contains length, and this length, one is length, another one is breadth, another one is height or depth. So there is three lengths are there. So length having unit meter, so meter be there, and because it is three length and product of three length is meter cube, so you just write down meter power 3. Now in symbol, how you can write down? The symbol of kilogram is kg and meter bm, power 3 is in denominator, so minus 3. So kg per cubic meter. This one is the symbol, unit by symbol and unit of density. Now next one is, suppose you have taken linear momentum. So linear momentum is the product of mass and velocity. So this one is mv, where m is mass, v is velocity. So the unit of mass is kilogram. Into unit of velocity. You know the unit of velocity is displacement by time, and this one is written by meter by second. So meter by second. Now in symbol, how you can write kilogram, that is kg. Meter is in symbol meter, m, and second is in symbol s minus 1. So kg meter per second. One more derived. Suppose acceleration is there. So acceleration, you know, acceleration is velocity by time. This one is velocity divided by time. You know, velocity is how much? Velocity is displacement by time, that is meter by second. So you just write down there is meter upon second. For time, for velocity, meter per second. And now once again you have to write down the unit of time once again. So there is one more second. That means what? There are 2 seconds. So you can write down this one, meter by second power 2, that is square. Right now we say how you can write down. For meter there is small m, for second there is small s having power 2, so 2 be there, but this one is in denominator, so for this one there is negative sign. So meter per square second. Meter per square second is the unit of acceleration.